So here's another sample of solving a rational inequality using graphs and tables. We're going to look at this problem here in our calculator using the graph and the table. So go into my calculator, document 44, to add a new graph. And then control divide, type in my left side, which is negative 2x minus 3 for the top, and then x minus 4 for the bottom, and enter. There's that. And then push tab, and then graph the right side, which is 0. And I'm going to add in the grid, so menu, view, grid, lined grid. I'm going to move this equation out of the way for us. Okay, so, and snapshot that to right on it. Okay, so back over here where the problem is at. We need to know about, first we need to know about our asymptotes to help us answer this question. We also need to know where they're intersecting, so I'm going to go back on my calculator and I need to know when are these going to intersect. That's going to be critical for my answer. So menu, analyze intersection, and it's right here is where it's intersecting. So going back. Okay, now that's better. So now I need to know my asymptotes. Looking at the denominator will help me determine my vertical asymptote. Vertical asymptote is at x equals 4. My horizontal asymptote, this is a situation where we have the same power of x's on the top and the bottom. And when that happens, you have to do your ratio of the coefficients. So it would be y equals negative 2 over 1, which is y equals negative 2. So my horizontal asymptote is at negative 2. And my vertical asymptote is going to be at 4. So those are my asymptotes. Now the question is asking, when is the graph greater than 0? So I need to go into the graph and I need to find when it's greater than 0. Well, this part down here in the bottom right, that part is never going to be more than 0 because of these asymptotes. It can never cross those, so it's never going to reach up here. So the only part that's accessible for this answer is this part of the graph. And to be greater than 0, if they're equal to 0 right here where they're crossing, the greater than 0 is where the pink line is higher, and that's over here in the graph. And remember that it's going to approach that asymptote, but it's not going to touch it. So we need to figure out like our boundaries. It's equal to 0 at negative 1.5. So at negative 1.5 is not going to be included because it doesn't have the equals bar in the equation. So negative 1.5 is as far left as we're going to go. Now we need to look at the right side. The vertical asymptote is at 4. It's going to get infinitely close to 4, but it's never going to touch it. So since it's never going to touch 4, the 4 is not included, and since it doesn't have the equals bar here, the negative 1.5 is also not included. So the answer to this question is from negative 1.5, but not including it, and that's why it's in parentheses, up to 4, and not including the 4 because that's the asymptote, so it's never going to touch that value. So these are the answers. This is the area and interval notation that you have. If you want to write that in set notation, negative 1.5, not included, so just less than x, less than 4, because neither one is included. So either of these methods for writing the answer are correct.